America, 1968. The muscle car era was detonating. You had the Mustang, the Camaro, the Barracuda, and the GTO. Every engineer in Detroit was chasing the same dragon: how to cram a bigger V8 under the hood, how to hook the tires to the asphalt, and how to stop the whole machine from shaking itself into scrap metal. Stopping was usually an afterthought. Every driver back then knew the ritual. You'd be doing 70 on a two-lane highway, you'd hit the brake pedal, and you'd feel that sickening shudder. But in a secret engineering bay in St. Louis, a team working on the new Chevrolet Corvette C3 did something that still makes professional mechanics scratch their heads today. They decided to stop braking the wheels altogether, and instead they tried to crush the heart of the car while it was still beating. What you are about to hear is not a rumor, it is not a concept sketch from a design student, it is a fully functional, test-verified, bizarre piece of American engineering.
The Corvette in the late 60s had a problem. Actually, it had several, but the one keeping the engineers awake at night was unsprung weight. If you are not a suspension nerd, unsprung weight is the mass of everything not supported by the springs: the wheels, the tires, the brakes. Heavy brakes, especially heavy disc brakes, do not like to move up and down over bumps. They fight the suspension. And on a car as low and stiff as the C3 Corvette, heavy brakes turn the front wheels into sledgehammers. So one night, and this is speculation, but it fits the character, some engineer looked at the spinning drive shaft underneath the tunnel and had a dangerous thought. That shaft is always spinning. It is connected directly to the rear wheels. If I grab it, I stop the wheels. And the drive shaft is dead center in the car, zero unsprung weight. That is the origin of the central start brake.
The team built a prototype. They used a massive drum brake assembly, like something from a light truck, and mounted it directly to the drive shaft. When the driver pressed the pedal, a set of hydraulic shoes expanded outward against the inside of a drum that was spinning at the same speed as the rear wheels. Now stop and imagine that for a second. You are driving a Corvette. You are doing 60 miles per hour. The drive shaft is spinning at roughly 3,000 revolutions per minute. For low-speed driving, the central start brake was surprisingly smooth. Because the brake was clamped directly to the driveline before the differential, there was no brake dive. The nose did not dip, the rear did not squat. The car simply slowed down as if an invisible hand was gently squeezing the entire powertrain. The team logged over 15,000 test miles on a modified 1969 Corvette convertible.
With the central start brake, the Corvette stopped from 60 miles per hour in 138 feet. That was only 3 feet longer than the production disc brake system. But here is the kicker. The stopping distance was consistent. No fade, no pulling to one side, no vibration. Because there was only one brake, there was no imbalance between left and right. That is a problem that plagues every car on the road today. The test cars started eating differentials. The ring and pinion gears would overheat and howl. The spider gears would crack. After about 3,000 miles, the rear end would sound like a bag of hammers. The engineers tried to solve it. They upgraded the differential cases. They used thicker oil. They even experimented with a one-way clutch that would disengage the brake under heavy load. Nothing worked.
Instead, they proposed something even more bizarre. They suggested a two-brake system: a small conventional disc brake at the front wheels for steering stability, and the central start brake at the drive shaft for the rear. That way, the differential would only see half the load. They built a prototype of that system too, and it worked better, much better. The car stopped flat. It turned into corners with zero brake-induced understeer. It felt like no other Corvette before it. Then, the lawyers got involved. You see, there is a problem with putting the emergency brake on a drive shaft. If the drive shaft breaks, and drive shafts do break, you lose the emergency brake entirely. Federal safety regulations at the time required a mechanical parking brake that worked even if the hydraulic system failed, and a drive shaft mounted brake could not guarantee that. So the project died. Not because the engineering failed, but because a lawyer pointed out that if a drive shaft snapped on a hill, the car would roll away with no emergency brake at all.
GM buried the central start brake in late 1969. The prototype cars were quietly dismantled. The engineering reports were filed in the basement of the tech center, and the Corvette team went back to bolting heavy disc brakes onto the wheels like everyone else. 2 years later, the Corvette 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 But here is where the story gets strange. In 1971, Chevrolet actually filed a patent for the central start brake. The patent drawings show the drum mounted on the driveshaft, the hydraulic lines, everything. And for a few months, rumors spread that the 1972 Corvette would debut the system. It never happened. The last anyone saw of the prototype was in a scrapyard photo from 1975, a white Corvette convertible with a weird bulge under the transmission tunnel. Then it vanished.
So why does this story matter? Because 40 years later, a crazy engineer at Volvo invented something called the drive shaft brake for their hybrid trucks. Same concept, same geometry, and it worked. The central start brake was not a failure of physics. It was a failure of timing. If GM had waited for stronger materials, better differentials, and electronic safety backups, we might be driving cars today with no wheel brakes at all. But they did not, and that is why the 1969 Corvette prototype remains the strangest braking system ever bolted to an American sports car. The engineers solved the weight problem, they beat the dive problem, they even tamed the differential problem, but they could not beat the lawyers. Now let me take you inside the mechanism itself.
The engineers at Chevrolet solved this with a device they called the pressure rise limiter. It was a small hydraulic valve, about the size of a cigarette pack, mounted between the master cylinder and the central brake. Its job was to delay the brake engagement by exactly 40 milliseconds. 40 milliseconds does not sound like much, but at 3,000 RPM, that is 2 full revolutions of the drive shaft. In that tiny window, the pressure rise limiter would feather the brake engagement, letting the drive shaft slow down just ahead of the car's momentum. It was like a mechanical hand slowly closing a vise rather than slamming it shut. The test drivers reported that the central brake felt bizarre at first. The pedal had almost no initial bite. You would push, nothing would happen for a heartbeat, then a smooth, deep tugging sensation would pull from the center of the car. It did not feel like braking. It felt like the car was swallowing its own speed. One engineer described it as pulling the car back by its spine.
And that brings us to the question nobody asked in 1969. What happened if the brake locked up? With wheel brakes, a lockup means a flat-spotted tire and a skid. Annoying, but survivable. With a drive shaft lockup, the rear wheels stop turning instantly. The car keeps moving. The tires are now sliding, not rolling. But here is the terrifying part. Because the brake is before the differential, locking the drive shaft does not lock the left and right wheels equally. The differential will still try to send power to the wheel with the least resistance. So in a lockup situation, one rear wheel could keep spinning while the other stopped. That would send the car into a spin so violent that the test drivers nicknamed it the corkscrew. Amazingly, GM's own test logs record that this happened exactly twice. Both times, the driver walked away, barely. One of those drivers wrote in his log, "Car rotated 270 degrees, stopped facing oncoming traffic. Recommend discontinuing this test." The engineers did not discontinue it. They added a second pressure rise limiter. And somehow, that worked. The central start brake never locked up again across the remaining 8,000 test miles.
The last anyone saw of the prototype was in a scrapyard photo from 1975, a white Corvette convertible with a weird bulge under the transmission tunnel. Then it vanished. The central start brake was not a failure of physics, it was a failure of timing. If GM had waited for stronger materials, better differentials, and electronic safety backups, we might be driving cars today with no wheel brakes at all. The engineers solved the weight problem. They beat the die problem. They even tamed the differential problem. But they could not beat the lawyers. The 1969 Corvette prototype remains the strangest braking system ever bolted to an American sports car. A what-if story written in steel, rubber, and forgotten patent filings.